received an email from a Perth-based company that converts classic cars to EV. And I noticed reading down this newsletter here, converting a 1993 Range Rover powered by a Tesla 3 motor mid-mounted. And at first, it seemed like an interesting idea, but then I started wondering, well, how is that actually going to work? So I believe that what this does is, instead of the existing motor, gearbox and transfer case, they're replacing all of that with a Tesla 3 motor and having a drive shaft to the front and rear axles to keep it as four-wheel drive. So I thought I'll do a bit of calculation and let's have a look to see if this actually adds up. So this is a different model of Range Rover. This is a classic 1980s Range Rover 3.5 litre V8 motor, and if you factor in all the gear ratios and so on, in low range these are calculations of the torque produced at the wheels of the vehicle. So it takes into account all of the different gear ratios, transfer case, differentials and so on, and size of the wheels. So in first gear low range, it produces a very high torque at the wheels, and then drops down, and at highway speeds it's much less torque, but at much higher speeds. These are kilometres per hour. And four-wheel drives have a particular challenge because they need to be able to produce enough power at highway speeds to drive the car, but also at low range, low gear ratios, they need to produce quite a high range of amount of torque. And I thought, will the Tesla mid-mounted unit produce this amount of torque? So I did a bit more calculation, and all these graphs are the same for the Range Rover, but I've added the torque output from a mid-mounted Tesla unit. So this is a 335 kilowatt Tesla motor, which I believe is the largest one that they make. It's the rear drive unit for their four-wheel drive Tesla. It produces 450 Newton meters of torque. It's been modified. I believe that there is the transfer or the differential in that Tesla unit has been geared down from about 9.3 to 3.54. So it's not as highly geared because otherwise it would have very little highway speed. So assuming it's got the 3.54 ratio in the actual Tesla unit, and it's the 335 kilowatt 450 Newton meter motor, you can see that at highway speed on the highway it's fine. It produces a little bit more power than the existing V8 motor. You don't want to be running at full power, so the reason why this drops down is that at this point, although the electric motors are capable of producing a fairly flat torque curve, at some point the battery is not able to deliver enough power to the motor, so they have to limit the amount of power that comes out of the battery, and so you get this quite rapid drop-off. As you increase speed, you lose torque, just because that's how much power, system can produce. So at highway speed, it is above what the Range Rover requires to drive it. But look at the low range area. It's less than half of the power, the torque that the original Range Rover has, which means that in off-road, if you're in sand or trying to pull through boggy conditions, you're not going to have the same torque that you would have in the original vehicle. And maybe that's fine. Maybe people don't expect to drive their electric Range Rovers in difficult conditions. But I'm just wondering, are these companies, and I believe there's several in Australia that are using or planning to use Tesla motors for converting Range Rovers and similar vehicles, are they actually telling their customers that it will not have the same off-road capability that the original car had?